Yesterday's lecture we have seen this relational operator. So relational operator are the comparison operator. So it's greater than equal to, less than equal to, not equal to. So these are the binary operators. So it need two operand to perform a task. So all the relational operator are maybe 0 or 1. So it will compare either this is the true or false only. If it is condition will become true, then it will give 1, false that 0. So relational operator will not modify the operands. Next we have seen logical operator, logical and, or, and not. And or are the binary operator, and not is the unary operator. So this also comparison operator. So it will not modify the operands. So this is the truth table of ending and oring. So ending that means multiplication, and oring that means addition. And this is the not, that means wherever 0 there 1, 1 there 0. And we have seen where we are using in the real life. So in the condition we have two types of condition, and both are we want to fulfill. At the time we are using the logical and. If any one are true, at that time we have to pass this condition as true. At that time we are using or. So like that, the real life we are using logical operator. Next we have seen type conversion, implicit type conversion and explicit type conversion. The implicit, that means the automatic type conversion, our compiler itself it will conversion. And next one is the explicit type conversion. Today we will see. So in implicit type conversion, character will automatically convert into the here decimal value. So that is my integer, and integer is automatically convert into the form of character. So this is implicit type conversion. Next we will see the explicit type conversion. In explicit type conversion, there may be some situation where implicit type conversion is not work as per our requirement. Suppose I will write here code. Suppose I will write integer a is equal to 20 and b is equal to 3, and I will do plot. Now f is equal to a divided by b. What is 20 divided by 3?
6.
But we want output in the form of float,
Yes. So 6.66.
because I am storing in the float. So here my output is 6. I want in the form of float 6.66. How? So here what happens whenever I am doing here a divided by b, my a and b both are the integers. So here a is also integer and b is also integer. So both are integers. That's why 20 divided by 3 is in the form of integer, and then after we are storing data in the form of float. That's why it's 6.000. I want this data in the form of float at that time temporary. What we are doing, we are telling to compiler I want this output in the form of float. So I will write explicitly here float. Now
Yogin, can you please once again explain the logic why
yes, yes,
it did
yes,
not?
yes, yes, I will. So my output is 6.66. So I will remove this float. So now here my a is integer type and b is also integer type. So 20 divided by 3 is 6. 6.6 instead of 6.66 it's 6, because both are integer. Okay. So I will write in here in the rough.
Uh, but we are trying to like print the float value. Then why doesn't float, as in it does not print the float value?
It is printing the float value only. So that's why, just a second. So see here what happened in this particular line. F is equal to a divided by b. A is integer, b is integer. Okay. So
Yes.
f is equal to 20 divided by 3. So f is equal to 6. This is my integer value. Now I am storing 6 in the form of float, and printing here form of the float is 6.00000. Why is 6.000? Because it's float. That's why 6.00000.
Okay.
Okay, understood.
Yes.
Mhm. So now what I will do, f is equal to, I will write float a divided by b. Now my a will become in the form of float. Explicitly I am telling compiler temporary my a will be here for this line float, convert to the float for temporary. So this is called explicit type conversion. Temporary we are telling compiler to convert my this variable as for this particular line working as a float. So what that it will do, so it will 20.000 and divide by 3. That means this will be like float format. So my output is 6.66666. So wherever this type of situation happen, at that time we are explicitly in that particular line temporary. We are telling compiler this particular line I want output in the form of float. I want this particular line how I want this part output in the form of integer, like that way. So we are converting by ourselves. Here I will write float. So now my output is 6.6666. So here my a will convert it to float type. This whole expression will not convert it to the float type. Suppose I will do like this way. Then what is my output? So I will run this code. Now my output is 6. Why? Because in this particular line, this is the flow is from right to left. So highest priority to both the parentheses, but this is the right to left. That means first this will resolve. So it will do 20 divided by 3. And my output is both are integer 6. And next it will convert into the float. So I will remove this parenthesis. Then my a will convert to the float type. So it's 20.0000 and divided by 3. So highest priority is the float compared to integer. Character, then integer, then float, then double, like that way priority. Yesterday we have seen that the priority list. So like that way, character, short integer, long integer, and float. So that means here float have highest priority compared to long integer also, because the float is storing real number, and then after double and long double. So because of that reason, here my a will convert into the float format, and then 20.000 divided by 3, that my output is 6.66 is stored into the float format. So for example, I'll write integer then 20.3. So what is the meaning of this particular line? That means my 20.3 is the float data will explicitly convert into the form of integer. So here 20.3 converted to integer. Next, float 20 divided by 3. Here 20 convert to float format. So this is similar. Here first priority 20 divided by 3 and second priority to float. So first 20 divided by 3 is 6. Second it converted to float. Suppose I will do double x plus y minus z, like that way expression. So what is the meaning of this line?
Output will be in the double.
Yes, exactly. So first it will solve this expression, and whatever the output of that, these are suppose my integer data or float data or whatever data. So that expression output will store into the double format. Similar way, suppose I will write.
Yogin, I am still not able to understand how without the brackets it give us the float value, and with bracket, because even if like for flow, the second condition that you said where 20 is converted to float and then divided by 3. So how does then it gives an output in float? Because the float has highest priority. Is that the reason?
Yes. So what we seen yesterday in the implicit type conversion, in this particular line, k is equal to I multiplication with j. What is I and what is j? See, and my data is stored in the format of long integer.
Long. Hmm.
Why? Because j have the highest priority.
Right.
So similar way here, this is explicit we are doing. So my a is treated as a float, and float have highest priority compared to the integer. Because of that reason here, so this both line meaning now understood.
Yes.
Next is the double, and suppose I will write x plus y minus z. So here my x will convert into double format, and then after whatever the expression it will solve, and it will store in the format of double, because double have highest priority. Suppose I will store here my f is equal to 10.3, and suppose situation is that I want my float format in the form of integer. I don't want point whatever the value is available at that. So what we will do? F is equal to integer 10.33. Now I am printing here f. My output is 10.0000 because I have converted 10.32 into the form of integer. So as per requirement and as per situation, we have to use this explicit type conversion. Next is the bitwise operator, and or XOR, complement, left shift, right shift. So left shift, right shift also type of bitwise operator. So this is shift operator. This is called bitwise and this is binary. So it needs to operand to perform task. And next one is the bitwise OR. It also binary. Next is the bitwise XOR. It also binary. Then next is the bitwise complement. This is also binary. Bitwise left shift, binary. Bitwise right shift. So all these bitwise operator will not modify the operands. And one more thing, bitwise operator will not applicable on the form of real numbers. So float and double are not possible to apply it. So bitwise operator are not applicable to real number. So float and double are not possible to apply it. So bitwise operator will not modify the operands, and bitwise operator will not applicable to the real numbers. So we will write down again truth table. There is A, there is B, the A ending B, A ORing B, A XOR B, 0 0, 0 1, 1 0, 1. 0 multiplication is 0 0, 0 0 and 1. ORing, that means 0 1 1 1. XOR, that means here 0 1 1 0. That means whenever the both bits are same at the time, we 0 and 0 1 1 0 at the time 1 1. This is XOR. So write down this truth table in your book. Then complement is similar like not, but not is and a complement we have some difference. We'll see. So there is 0 where there 1 there 0. Next, bitwise operator will do perform on the bits. So suppose I will write here I is equal to 10 and j is equal to 15. Then k is equal to I ending with j. So what is the meaning? I first we have to convert into the binary. So I might 10 convert into the binary and 15 convert into the binary. So what is the binary of 10? 1 0 1 0. And what is the binary of 15? 1 1 1 1. Then we have to do ending operation of that. 0 ending with 1 0. 1 ending with 1 1. 0 ending with 1 0. 1 ending with 1 1. So my output is 10 will store into the k. Suppose I will do k is equal to I ORing with j. So at the time 1 0 1 0 ORing with 1 1 1 1. So here 0 ORing with 1 1 1 ORing with 1 1 0 ORing with 1 1 1 ORing with 1 1. So my output is 15 will store into the k. So whenever you have to do bitwise operation, at that time you have to compulsory convert into the binary format, and you have to do ending operation of that, ORing operation of that. So like that way you are doing XOR. Suppose k is equal to I XOR j. So at that time 1 0 1 0 1 1 1 1. What is 0 1? Is 1 1 1 is 0 0 1 is 0. Sorry, 1 here and here 0. So 5 will store into the k. So bitwise operation is performing with the bits. So what is the difference between logical operator and the bitwise operator?
Yeah, logical we used to compare the conditions, and here we did for binary we do operations. Yes.
Mhm.
In logical, we get an output of either 0 or 1, even if we are doing like non-zero numbers. Here we'll get some value to as an output. For example, when we perform the n, we get an output of 10, like not in the form of just 0 and 1 or true or
Yes.
false.
Yes.
So in logical operator, we are using for the condition checking. So it will give output in the form of true and
One or
false
two.
only. And bitwise operation is the performing with the bits. Why bitwise operator is very very much important? So we have 1 byte data or 4 byte data. So 4 byte data, we have how many bits? Suppose 4 byte data, then how many bits? 32 bits we have. So we run 32 bits, 32 lights, 32 outputs. Each and every bits are important for us. So we have to perform task in each and every bits. At that time we are using the bitwise operator. I have to clear particular number bit, I have to set bit, I have to do operations on that bit in the shift operator. So because of that reason, bitwise operator is very very much important. Instead of different 32 data types I will use only one data type, and each and every bits I will use as a different applications. We save much more memory. So the main purpose is the we have to perform on the bits. So what is complement? Suppose I will do I is equal to 10 and k is equal to complement of I. So first,
5.
no, it's not 5. First convert into the binary. Yeah, for that it's 5. Yeah, 1 0 1 0. So it will wherever the output will 0 1 0 1 and my output is 5. But this is in not like that. Why? My integer is form of 4 byte data. So I will write here 0 0 0. And now I have to do complement of I. So this all will become 1 1. and this sign become 1. Whenever this sign will become 1, that negative number will store. So how to identify this number is which one in the form of negative? So what again we need to do? 2's complement concept. Understood? So first again we have to convert this into the first complement 0 1 0, then plus 1. 0 plus 1 is 1, then 1 1 0 1. Rest of all are 0 0 0 0 0. So what is the 1 0 1 1 1? Answer is minus 11. This is 11, but this is negative numbers. So again I explain. I have taken I is equal to 10. So what is the k is equal to complement of 5? That is not 5. Why? Because so we have to not do like this way. In our memory, I is the integer data type. So that's why it's stored in the 4-byte data. And when we do complement of I, so the output is 1 1 1 1 1 1 1 1 0 1 0 1. So this sign will become 1. That means my number is negative. So we have to convert this number. What is exactly number? So for that, what we will do, 2's complement. Negative numbers are stored in its 2's complement. We have already seen that concept. So we have to convert its first complement here. Then we have to do plus 1. That is my 2's complement. And my output is 1011. That is minus 11. So this is the most important question for interview. What is the difference between logical operator and the bitwise operator? And signed and unsigned, that is also one more important question here. This is the form of signed and unsigned. You have to know about this concept. So every day we will link with each other. At the last day, we know each and every concept. At that time we will make one big projects and big assignments. At that time you have to use all the concepts. So each day we are linking with each and every concepts. So please do practice and do revision regularly. Each and every concept is important. So whenever you start program, write down these things first. Then integer I is equal to 10 comma is equal to 15, and I will take one more integer k.
So, Yogin, I have
Yes.
written this code. So, I
Mm-hmm.
have done I equal to 10, j and j equal to 15 and comma k. Why you
Okay.
have separated separately
So
uh,
both meaning are same. So
same
we can write, yeah. So you can write I integer I
comma
is equal to 10 comma instead of I will write integer j is equal to 15.
separate.
Both are same.
Hmm.
There is no any difference. So k is equal to I ending with j. So printf here k is equal to percentage d. Here I will do k is equal to I ORing with j is equal to I XOR j. Okay, so I will run this code. As we have seen already, the expected output is what is I and j? 10, 15 and 5. Next, one more method for swap two numbers using bitwise operator. Suppose I have two numbers, n1 is equal to 10 and n2 is equal to 15. Here, these two numbers I have. So I have to swap these both using bitwise operator. Suppose you will do XOR of both that 10 and 15. So what we get output here? 5. N1 is equal to, suppose I will do N1 XOR with N2. What is my output here? 5. So 5 will store into the n1. So my n1 now become 5 and n2 is equal to 15. And then I will do n2 is equal to n1 XOR n2. Now what is my 5 and 15 XOR? So 15 is 1 1 1 1 and 5 is 0 1 0 1. So 1 XOR with 1 is 0, 1 XOR with 0 is 1, 1 XOR with 1 is 0, and here 1. So my output is 10 will store into the n2. So my n1 is here 5 and n2 is here 10. Again I will do n1 is equal to n1 XOR n2. I will erase this part. So what is output here? n1 is equal to n1 XOR n2. What is my n1? n1 is 5, n2 is now 10. So my 1 0 1 0 will XOR with 0 1 0 1. So my output is 0 XOR with 1 is 1 1 1 1. So this 15 will store into the n1. So my n1 will become 15 and n2 become 10. So my both number are swapped. This is one more method for swap two numbers using bitwise operator. So we have seen method of using the arithmetic operator, using temporary variable, and this is the third method using XOR operator. In arithmetic operator, we have seen different three methods. One using array addition and subtraction, one using multiplication and division, and one using the single line code. And this is another method for swapping two numbers. So I will write this logic here. Where is my swapping method code? Here. Here what we have to do, n1 is equal to n1 XOR n2. Then n2 is equal to n1 XOR n2. Then n1 is equal to n1 XOR n2. So I will open integrated terminal gcp5.c 10 and 20. So my bigger number will not get swapped. Why?
Equal to sign, last line.
Yes, that's mistake. So here it's 20 and 10. So write down this logic in your notebook wherever you have written swapping of two numbers code with there. I will cover one more operator, that is the conditional operator. So conditional operator we can call as a ternary operator, and it need three operand to perform task. So that syntax is like this way. First one expression or any constant or any condition, whatever that output is in the form of non-zero or zero. Generally we are using here condition. So first expression, then question mark, then here it is true. If this condition is true, then it will go to here and do this, whatever the expression is here. So here we are writing the expression. Then if it is false, that means zero. So it will go to here and it will do solve expression like this way. So similar, if you know concept of if else, no, if don't worry if you don't know. So here in the case of if I have here condition, if this condition will become true, then it will go to inside and it will do that work. If this condition will become false, it will go to the else part and it is doing that task. Similar way, if this condition will become true, then it will go to the here and it will do whatever written that task it will do. If condition will become false, it will go to here and it will do this task. So write down this syntax in your book. Forget about this if else part as of now. I will go here and I will write one code. So integer I is equal to 10, j is equal to 20, and k is equal to percentage d, j is equal to percentage d. And what is the my value of I and j? I will not print here k. Suppose I will do here k is equal to I less than j. If this condition will true, at that time I have to print store inside the k 100. If this condition will become false, at that time I have to store 200. So what is the meaning of this line? First is this my condition. If this condition will become true, then it will store 100 into the k. If this condition will become false, so 200 will store into the k. So what is 10 less than j? Sorry, 20. This condition is true or false?
Is it true?
Yes, 10 less than 20 is true. So 100 will store into the k. So I print here I, j and k. If I it's p13.c. So my k is 100. Suppose I will write here I greater than j. Then
200.
yes, exactly 200 will store into the k. Suppose I will do here. Here you can write any expression or anything. Now I greater than j. Suppose my I is equal to 10, j is equal to 20. So 10 greater than 20. Condition is true or false? So condition is false. So I is equal to 200. Here I am changing the value of my I also. And inside the k, whatever the value is stored. So my k will be 200 and I will be also 200. So this is for example purpose only. See here, my I will change here and k, whatever the data of I is stored into the k. I am giving one homework to you for this conditional operator. You have a two number here. So you have to print here which number is bigger. So your homework is write a program to find bigger number. You have to print I is bigger or j is bigger.